Right, in this video we're just going to introduce a few different ways in which we can define sequences and a few different definitions to do with sequences. So first off, we can get an nth term sequence. So this is where we have some sequence an and it's defined by the term number. So it's defined by an is some function of the term number. Okay, so if someone says what's the third term, you can use, you find A3, which will be F3. So an example of this might be a sequence an where the terms are defined by an's equal to 3n plus 4 over 2n squared plus 7n plus 1. Okay, so that's pretty simple. Second type of sequence is an iterative sequence, and I'll just put IT, and this is where a sequence xn is defined in such a way that xn plus 1, the next term in the sequence, is defined as some function of the previous sequence, or perhaps the previous couple of sequences. So an example might be xn plus 1 is equal to 3xn plus 2. So obviously for these sequences to work, you have to be given so you have to be given the initial terms, okay? And if we do another example, maybe xn plus 1 is equal to 2xn squared minus xn minus 1. Well, here x1 and x2 are given, and then you can find x3, x4 and so on yourself. But of course that sequence is not defined if you don't have any initial conditions. Whereas for these ones you just give the rule and you're good to go. Right, next up we're going to look at increasing sequences. So this is pretty simple. If an plus 1, so if as the term number increases, this means that term in the sequence is bigger than the previous one, and that's for all n, then that's an increasing sequence. So for an example, an is equal to n squared. Decreasing is the opposite, so an plus 1 is less than an for all n in natural numbers, and for all n in natural numbers if we want it to be increasing or decreasing for the whole sequence. But it could be, the sequence could become increasing once an reaches a certain term, so it could be oscillating or whatever up to the 30th term, and then it could be an increasing sequence. So it could be increasing on that range, so that's another thing to think about. But in terms of what's an increasing and decreasing sequence, it's for all of them. So an example of this might be, yeah, let's just make sure we know that's an example, right? An's equal to minus n for all n natural numbers. See, as n gets bigger, minus n gets bigger in magnitude, but it's negative, so clearly this is getting smaller. Last thing we'll look at is a periodic sequence. Handwriting's gone wild there. Anyway, so this is some sequence an where we get some sort of repetition. So we have a1, a2, first two terms, up to some term ap, and then after ap the next term is equal to a1, and then we get a2 up to ap, and this just continues, okay? And an example of this, often the sine and cosine functions this, but I'm going to actually define a slightly more complicated function in terms of the derivatives. So we could take a function an, and when we talk about sequences, in the brackets represents the whole sequence, whereas this represents a term. So when I write an, this is how the terms are defined in the sequence an. And I'm going to write this as dn of sine x dxn. So this represents the nth derivative of sine x. So if we take a look at an, and n's going from 1 onwards, the first derivative of sine x is cos x, then the second derivative of sine x is the first derivative of cos x, which is minus sine x, and then the derivative of this is minus cos x, the derivative of that is sine x. Now we get cos x minus sine x minus cos x, sine x, cos x, and so on. And you can see this sequence just repeats the same 4 terms over and over. And sorry for that terrible drawing, and that's what we call a periodic sequence. Okay. And we might look at a few more examples of this in future videos, but as we go on to talk about sequences and series, we're going to look at arithmetic sequences, geometric, and we're also going to look at sigma notation for sums of sequences. If you do have any questions about any of the definitions introduced in this video, or anything you want to be covered in this little A-level math series on sequences, be sure to let me know in the comments. Also, if you came onto this video and perhaps you are an A-level student but you're looking for some more information on sequences and series that are not perhaps on the specification, then be sure to check out my series just on that I'm currently making. I'll leave that linked, which is perhaps a little bit more higher level than you'd have to do at A-level, but will certainly help you, especially if you're looking to go on and study maths further. If you did enjoy this video, please be sure to like and subscribe, and I hope to see you in